Good morning. Myself, Prabha Ranjay, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, we are going to discuss about the topic name is state models for linear continuous time system, which is an important topic under state variable analysis in linear control systems. In classical control systems, we use transfer function to represent systems. However, transfer function becomes difficult when dealing with complex and multi-input, multi-output systems. To overcome these limitations, we use state space representation, which describes the system using state variables and first order differential equations. In this session, we will understand the state model through the perspective of design thinking, making the concept easier. Before solving any engineering problem, we must understand the system completely. Linear continuous time system form the backbone of many engineering applications such as robotics, aircraft control, power systems, industrial automation. The challenge is that system behavior changes continuously with time, making analysis difficult. Traditional methods focus heavily on mathematics. While mathematically accurate, they may not always provide intuitive understanding. Therefore, we adopt a design thinking approach to simplify the understanding of state models. We know the first stage of design thinking is empathize. In control systems, this means understanding how the system behaves. Think of a system as a user whose behavior we want to understand. We study how the system changes from one state to another, what inputs affect the system, what output are produced, what disturbances may occur. State transition diagram help us visualize these changes clearly. Understanding the systems thoroughly is the first step toward building an accurate model. Second stage of design thinking is define part. Before solving a problem, we must clearly identify what variables describe the system. In state space analysis, we define state variable represented by small x of t. These variables completely describe the system's conditions. Input variable represented by u of t. These are external signals applied to the systems. Output variables represented by y of t. These are the measurable responses of the systems. By identifying these variables correctly, we create a foundation for state space modeling. The third stage of design thinking is nothing but the ideate stage. Here we brainstorm different ways to represent the system. The most important representation is the state space model. We also consider a feedback loop which continuously compare output with the desired value and correct value. Now let us have the small classroom activity. Here you can see the puzzle question on your screen. Your job is you have to find the value of the question mark position. And fourth stage of design thinking is the prototype. Once we define a model, we create a representation of it. We build state transition prototypes. These show how the system moves between different states. Simulation methods or simulation test. We test the system using step input, ramp input, impulse input. Simulation help us understand system behavior before actual implementation. For more complex systems, advanced methods such as fuzzy cognitive maps can also be used. The last stage of design thinking is the test. After creating a model, we must verify whether the behaves correctly. Testing involves applying input, observing output, comparing actual behavior with expected behavior. If the tests are not satisfactory, we refine the model. Testing ensures that the state model accurately represents the real system. A validated model can then be used for controller design. Now, let us see the benefits of combining design thinking with state model. We know design thinking provides human-centered understanding, creativity, better problem framing, then intuitive learning. A state model provides mathematical precision, accurate analysis, prediction of system behavior, controller design capability. When we combined these both design thinking and state model, they create a powerful framework for understanding and designing control systems. The future of control engineering requires both analytical and creative thinking. Using design thinking, we understand the system better, we model the system accurately, we design better controllers. The process can be summarized as understand, empathize with the system, model, define state variable and equation, and design, develop robust control strategies. This approach helps engineers build smarter and more reliable systems. Now we are in the assessment quiz part. Let I check your understanding through this assessment quiz. Here we have two assessment questions. First one is, which methodology is introduced in the presentation to better understand state models? Option A is Six Sigma, option B is design thinking, option C is lean manufacturing, option D is agile development. Which one is correct? Correct option is option B, design thinking. And second quiz is, the input variable in a state space model is represented by which here you can see the four option. Which one is correct? Option C is correct option. U of T is correct option. If you have any doubt, you can ask me through the comment. We will meet in next video. Thank you.